All right, hi everybody. Um, let's go ahead and get started. Thank you so much. You guys did an awesome job yesterday. I know it was a little bit confusing because we were exploring, we were learning a new thing at the whiteboards, um, which was a little bit different, but I definitely saw you guys were figuring things out, making some connections for yourself. So I really, really like that. And unfortunately, we didn't have time to get through this entire practice sheet. So I want to start off by just going through this together. So what I'm going to do is I'm just going to go for this top part. I'm just going to look at that first compound for all of these. And so um, what we want to do is we want to identify what type of compound that is and then write its formula. So when I see dichlorine monoxide, I know that chlorine is a nonmetal and oxide is for oxygen, which is also a nonmetal. So I have two nonmetals. This is covalent. Another hint here is that I have my prefixes. So this is going to be a covalent compound. And when I go ahead and name that, I look at the back of my periodic table where I have all my prefixes. I know chlorine is Cl, and that di means 2. Oxygen is O, monoxide, mono is 1. So my formula there is Cl2O. This second one, I'm seeing lead oxide. And so what I'm seeing here is I have this Roman numeral here, which is a hint to me that this is a transition metal. So automatically I know, hey, there's a metal in this. This is ionic. Well, when I go to write my formula, I start with my lead. I put my +2 up here. My oxygen is my -2. Oh, I look at that +2 -2. That equals 0. I'm all good. So then when I do that, I go ahead and I just leave it as PB0. I do not write those charges in my final answer. What I notice about number 3, again, I have another transition metal. But I also have something that does not end in "ide." So there's no "ide," and what that tells me is I have a polyatomic ion. So this is definitely ionic. When I go ahead and get started here, okay, I write out my iron. I'm going to switch colors here so it's a little bit easier to see. So my iron is Fe, and it has that +3 charge from my Roman numeral. When I look for perchlorate, I know to go to the back of my periodic table because it ends in 8, so it is a polyatomic ion. I get a -1. So I'm going to go ahead and use my crisscross method. And so I know that that 1 goes to iron. Well, I don't ever have to write a subscript of 1, so I'm just going to leave it as Fe by itself. And then I'm going to put parentheses around my perchlorate, ClO4, because there are more than one of them. And then I will put my subscript on there. That's what we do with polyatomic ions. We're going to do some more practice with this together in the video after we go through this. Rubidium iodide. This is telling me rubidium, that's a metal. So this is a simple ionic here. My formula, rubidium has a charge of +1, I believe. Iodide has a charge of -1. So that's just RBI. So that's our first set. Now if you went ahead and you wanted to do that second set here, newsflash, all of your choices were the same type. So I wanted you to do a covalent. I wanted you to do an ionic with a transition metal, an ionic with a polyatomic ion, and then a simple ionic. Iodine heptafluoride, there is no prefix on that iodine, so that means there's just one heptafluoride. Hepta is 7. Copper 1 sulfide, that's telling me my charge on my copper is 1. Sulfur has a charge of -2 from my periodic table. I get that charge from what I wrote in there looking at how many valence electrons it's going to gain. I'm going to crisscross method over here. Okay, so I end up with Cu2S1. We don't need the 1 in our formula, and we make sure we don't put any negatives there. Charges are gone. Strontium permanganate. Strontium has atomic number 38. That's in my alkaline earth metals. It has a charge of +2. Permanganate has a charge. It ends in ATE, so I know it's on the back of my periodic table. It has a charge of -1. I go ahead, I crisscross. Okay, so my strontium ends up subscript 1. I don't need it there. Permanganate ends up with subscript 2. So since that subscript's not 1, I do need to put my parentheses around it. Last one we got here is calcium fluoride. Calcium has a charge of +2. Fluorine has a charge of -1. If you want to do the mathematics method here, I have a +2. I have a -1 to make those the same. I need 1 calcium. I need 2 fluorines. CaF2. So that's a quick review of that practice sheet. I saw a lot of you guys absolutely crush those covalents. You crushed those simple ionics. It definitely got a bit more difficult with those polyatomic ions. So what I want to talk about next is just those things that we want to make sure we super duper know for your quiz on Monday. So we don't reduce for covalent. So if I tell you something where you end up with like a C2H4, we don't reduce. This is what we're going to leave it as because we want our formula to represent exactly what those prefixes tell you for dicarbon tetroxide. So even though in ionics we would reduce this and make it CH2, for a covalent we want to make sure we're representing, hey, 2 carbons, 4 hydrogens, just like what it says. Simple ionics, we do want to make sure we reduce. So if we have something like, I don't know, magnesium oxide, magnesium is a +2, oxygen is a -2. If you were to crisscross that, you'd end up with Mg2O2, which we would want to reduce to MgO. That one we do want to reduce because we have a metal. You also want to make sure you memorize your special transition metals that we do know have a charge. When we look at them in our periodic table, aluminum is right on those stairs with that charge of +3. And then if you go diagonally down, zinc has a charge of +2, silver has a charge of +1. You do need to memorize these for your test. You should definitely expect to see at least one of them on there. Transition metals, those Roman numerals tell you the charge on the metal, not the subscript. So when I tell you iron 3, really what I'm telling you is I'm telling you F+3, that charge on there. Finally, when I look at polyatomic ions, these are basically, my hint is that it doesn't end in "ide." It's going to end in something like "ate" or "ite." Something like that. That's not that IDE. We're always going to use parentheses when there is more than one of the polyatomic ion. So when you do your crisscross method and you got to put a subscript that's not 1 on your polyatomic ion, that's when we're going to use those parentheses. So let's go ahead and practice this together. I'm going to go to our practice sheet that is right next to, or the next page, right after our notes here. Okay, so we're going to start at number 14 down here. And this is going to get us some practice with those transition metals and the polyatomic ion. So it's going to be some really good practice here. So I have lead 4 here. So lead 4 is telling me that I have Pb plus 4, and then I have phosphate. So that's not an ide. So what that is telling me is that this is a polyatomic ion, and I need to look at the back of my periodic table. So when I find phosphate, phosphate is PO4 with a -3 charge. 4 plus -3 equals -1, so I can't just cancel those out. If I were to use my crisscross method here, I'd go ahead and bring my 4 down here, my 3 down here. So I'm left with PB3, or lead 3. And then since my subscript here is going to end up being a 4, it's not 1, I do need to put my phosphate in parentheses and then just write my 4 there. And that's it. Let's do another one. Chromium is Cr on our periodic table. This is telling me it has a +3 charge. Nitrate ends in ATE, not IDE, so that means it is a polyatomic ion. Nitrate is NO3 -1. +3 minus 1, that gives me -2, so this is not balanced. I need to use my crisscross method here. So chromium ends up with a subscript 1, but we don't keep that there, so we'll just write Cr. Nitrate's going to end up with a subscript of 3, so I need to throw it in parentheses so that I can tell, hey, this is one group. Go ahead, pause, try 16, 17, and 18. Okay, let's look at them together. So iron 3, Fe is my symbol for iron. 3 is telling me a +3 charge. Sulfate ends in ATE. That is a polyatomic ion. Sulfate is SO4 -2. I'm going to go ahead crisscross this out. So I end up with Fe2. My subscript on my SO4 is not 1, so I'm going to put it in parentheses and throw that 3 down there. Now, if your brain likes the math method and you know, hey, this is a +3, this is a -2, 3 times 2 is 6, so that means I need 2 irons, 3 sulfates for it to cancel. You do that. You do what works for your brain. Sodium sulfate, this is a nice one because sodium always has the same charge of +1. Sulfate, again, is that SO4 -2. When I crisscross, I end up with Na2. And then SO4 has that subscript of 1, so I actually don't need to even put it in parentheses. I can just write it straight out there because I don't write my subscript 1. The last one we're going to look at here is ammonium carbonate. Ammonium is weird. It's one of those polyatomic ions that comes first. If it ends in ium, you might want to take a peek at the back. Ammonium is NH4 +1. Carbonate is CO3 -2. We're going to crisscross this here. So then I end up with, I have NH4, I need 2 of them, so I'm going to put that in parentheses. And then CO3, I just have 1 for my subscript, so I'm going to leave it as it is. When you do this, we do notice that, hey, these are all nonmetals, but since we are looking at polyatomic ions, this is still ionic. So on your quiz on Monday, all of these things are going to be mixed together. You're going to have covalence, simple ionics, transition metals, polyatomic ions. So as you're studying, make yourself maybe a little cheat sheet that's giving you reminders of, hey, okay, when I don't see ide, that's polyatomic. when I see that charge, that's a transition metal.